Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So today we are going to talk about ionization energy and electron affinity. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus, Core 1 paper, Unit 2, Periodicity of Elements. So let's discuss what is ionization energy. So this is otherwise known as ionization potential or ionization enthalpy. So the amount of energy needed to remove an electron from a free gaseous atom is called ionization energy. So Mg, the free gaseous atom, so it will accept energy giving rise to M plus gas plus E minus. So this process is endothermic. So this is called fast ionization energy. Similarly, M plus gas will accept energy and it will give you M2 plus gaseous ion plus it will release another electron. So this is called second ionization energy. Similarly, M2 plus ion or gas will accept the energy giving rise to M3 plus gaseous ion plus release one electron. So that is called a third ionization energy or so on. So now if we write directly M gas, so that will give you M3 plus gas plus 3 electrons. So this is the combination of all three steps. Ionization potential 1, ionization potential 2 plus ionization potential 3. So the ionization energy is an experimental quantity and it is obtained either from spectra of gaseous species or by discharge tube technique. So for all elements, the value of successive ionization energy increases. So IE1 less than IE2 less than IE3 less than IE4 and so on. So it is due to the fact that the removal of each electron decreases the number of electrons. So consequently, the effective nuclear charge Z star increases and the remaining electrons are tightly held by the nucleus. It is difficult to remove the successive electrons, so hence second, third ionization energies become larger. The ionization energy is measured in electron volt (eV) or joules or kilojoule. So EV gives ionization energy per atom and kilojoule gives ionization energy per mole. So here you can see lithium atom. So it gives Li plus electron. So fast ionization energy is 520.1 kilojoule per mole. Similarly, Li plus giving rise to Li2 plus electron. So IE2 second. So that is 7297.2 kilojoule per mole. Similarly, Li2 plus giving rise to Li3 plus electron. So that give rise to IE3 that is 118.10 kilojoule per mole. So smaller the ionization energy, so the easier is to convert the neutral atom to into cation. So let's talk about what are the factors affecting ionization energy. So first is atomic size. So larger the atomic size, the smaller is the ionization energy. Then next is nuclear charge. So ionization energy increases with increase in nuclear charge. The next is the number of electrons in the inner shell. So the larger the number of electrons in the inner shell, the smaller is the ionization energy. The next is nature of orbitals, s, p, d, f electrons. So ionization energy follows this order, s greater than p greater than d greater than f electrons. The next is electronic configuration or stability. So the atom with half filled or full filled orbital in valence shell, so the ionization energy higher than the other. The next is variation of ionization energy. So ionization energy decreases in a group from top to bottom. So here you can see lithium, sodium, potassium, rubidium, cesium. So these are the values you can see. So lithium has highest 5.39 and cesium has 3.89. So in a group with increase in atomic number, so the distance between electron being removed and the nucleus increases. And due to addition of higher electron orbits in the configuration, therefore the attractive forces between the electron and nucleus decreases. So it results to decrease in ionization energy. Next is ionization energy does not change regularly in a period, although it has a tendency to increase. It is because all factors controlling ionization energy change in a period from left to right. So for example here, lithium, beryllium, boron, carbon, nitrogen. So here you can see the configuration and the orbitals involved and their radii and their effective nuclear charge. So that's why the ionization energy lithium is 5.39 and for nitrogen it is 14.53. So fast ionization energy beryllium is greater than boron. So beryllium has 2s2 configuration and boron has 2s2 2p1. So attractive effect is larger on s electron than p electron. So that's why beryllium has higher ionization energy than boron. Similarly, fast ionization energy nitrogen is greater than oxygen. So you can see here nitrogen 14.53. Here oxygen data is not given. So usually 2s2 2p3, that is the configuration, valence shell, nitrogen, and 2s2 2p4 for oxygen. So nitrogen is half filled. Okay, so this is half filled. So it has a extra stability. So removal of electron from oxygen is easier and hence have less ionization energy than nitrogen. Then next let's talk about electron affinity. So that is otherwise known as electron gain enthalpy, or we write EA. So the energy released when an electron is added to an isolated gaseous neutral atom is called EA. So the amount of energy released when an electron is added to an isolated gaseous neutral atom, that is called electron affinity, EA. So X gaseous neutral atom and energy electron will be added E minus, so giving rise to X minus gas plus energy EA. So the energy in the above process is released due to attraction between the nucleus and the electron being added. And electron affinity depend upon atomic radius. So when the atom is small, the attraction between the nucleus of the atom and electron is large and EA is high. For larger atoms, the distance between nucleus of atom and electron is large. So the attraction is small, so electron affinity will be small. So electron affinity or electron gain enthalpy is measured by analysis of ionization of a spectra of X minus. So oxygen will accept one electron giving rise to O minus, so plus energy. So this is exothermic process, minus 14 or minus 142 kilojoule. Similarly, O minus plus electron plus energy giving rise to O2 minus ion. So this process is endothermic, so that requires 844 kilojoule per kilojoule. So in the second step, E minus has to be added to O minus, and which naturally will repel that electron. So thus formation of N3 minus, P3 minus or S2 minus are all endothermic process. The next is variation of electron affinity in periodic table. So electron affinity depends upon the atomic radius. So electron affinity value increases across the period and it will decrease down the group. The smaller the radius of the atom, so larger will be the EA and vice versa. So atomic radius increases in a group from top to bottom. Therefore EA decreases in group from top to bottom. Atomic radius decreases in a period from left to right. So therefore electron affinity increases along a period from left to right. So here is the element hydrogen, lithium, potassium, rubidium and their electron affinity values. Similarly oxygen, sulfur, selenium and their electron affinity values. Similarly fluorine, chlorine, bromine, iodine. So for fluorine 3.45, for chlorine 3.61. So there is some exception. So EA electron affinity for fluorine is lower than Cl. So here you can see electron affinity for fluorine is 3.45 and for chlorine is 3.61. So fluorine atom is very small in size, so its electronic shell is in compact. So therefore large electron-electron repulsion between added electron and electron of fluorine atom. So hence fluorine atom has low electron affinity. So this large repulsion is observed in the expansion of size of F minus ion. So RF equal to 0.71 angstrom and RF minus equal to 1.35 angstrom. So EA measures the tightness with which it binds an addition of electron to itself. So EA is measured in electron volt per atom or kilojoule per mole. So if EA is positive, then delta H will be negative. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. For class 11th and 12th, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.